Your steps for solving linear equations tell you that you should get rid of adding and subtracting or anything that's not attached to the variable first before you get rid of multiplication or division. So I'm going to show you kind of some special cases where you have to be careful. Fraction bars are considered grouping symbols, so therefore it's almost like having to get rid of parentheses or distributing before you add or subtract. Kind of the same idea. We have to get rid of sometimes that fraction bar before we can do anything. So we're going to look at 3 examples. They're all somewhat different from each other, so please do make sure you watch all 3. So I noticed that on the first one, this fraction bar represents that everything on top is grouped together. So everything on top is being divided by this 6. So this is actually 3x over 6 minus 5 over 6 and 2x over 6. So rather than have to deal with a whole bunch of fractions, I'm going to go ahead and get rid of that 6 right away. And I'm going to get rid of it by multiplying the left side by 6 and the right side by 6. Because technically what I'm doing is I'm multiplying by 6 over 1. So the 6 is on top. I'm not multiplying the 6 by 6. I'm multiplying the left side by 6. That's helpful because now notice that my 6's will cross out over here, leaving me with 3x minus 5 plus 2x equals, and because I multiplied the left by 6, I have to multiply the right by 6, equals negative 12. Now I can go ahead and perform my usual steps for solving linear equations. I can combine my like terms on the left side. 3x and 2x is 5x minus 5 equals negative 12. Notice that when I'm working on one side, I don't change any signs. I'll get rid of add or subtract, so anything that's not attached to the variable, this minus 5, I'll add 5 to get rid of that. And then I'm going to end up with 5x, sorry I don't have a lot of room, equals negative 12 and positive 5 is a negative 7. Divide by 5 to get x by itself. My 5's cancel and I get x equals negative 7 over 5. So this was a situation that because all of these were being divided by 6 because they're all grouped together on top, where I actually got rid of the division first. Now on example 2, notice the only thing that's being divided by 5 is the 4x. It's just one term. So this is a situation where I'm actually not going to get rid of division first. So I'm actually going to go ahead and try to combine like terms. Well, look I have 4 over 5x and 3x over here. Well, in order to combine those, I know I'm going to have a common denominator. I know they're like terms because they both have x's. It doesn't matter that one's a fraction and the other one isn't. So I'm going to go ahead and multiply here by 5 and here by 5. Those are 5s, they're hard to read. And I get 4. This is 4 times x divided by 5. I can write that as 4 over 5x. It means the same thing. Minus 6 plus 15x over 5 equals 7. Now I can combine my like terms. 4 over 5x and 15 over 5x is 19 over 5x. Minus 6 equals 7. Now from here I can go ahead and say I'm going to get rid of anything that's not attached to the variable. I can get rid of the minus 6 by adding, giving me 19 over 5x equals 13. So now from here, how do I get rid of 19 over 5? Well, if you remember, if you multiply something by its reciprocal, everything cancels out. Everything turns to 1. So what I'm going to go ahead and do is I'm going to multiply this side over here by 5 over 19, and that's allowed as long as I do the same thing to this side over here. The reason this is helpful is because notice that over here on the left, my goal, remember my ultimate goal is to isolate the variable, my 5's cancel and my 19's cancel, leaving me with just x. X is alone on one side. 13 times 5 is 65. And then I just keep that 19 because remember when we add fractions like we did here, we need to have a common denominator so we can keep it. When we multiply fractions, we multiply straight across. Technically this was 13 over 1, so 13 times 5 and 1 times 19. Looking at the final example. Okay, so notice here, these are all being divided by 6. The negative, or the minus 3 is not. So I have a couple options here. I would like to be able to get rid of this 6 on the bottom, but I can't unless I get rid of the minus 3 first. Notice I got rid of the 6 here right away because it was under everything. Notice here I wasn't able to get rid of my fraction until everything contained that same denominator. So what I'm going to go ahead and do is I'm going to get rid of this plus this minus 3 by adding 3 to both sides, giving me, and I'm also going to go ahead and distribute at the same time too, since I know I'm going to have to do that in the future anyway. Giving me 2x plus 4 all over 6. My 3's cancel out, equals. Remember, I can add this 3 to anything that's like a like term of it over on the right, so I'm going to add 8 and 3, giving me 11 minus x. And now from here, notice this looks a lot like example 1. So I'm going to go ahead and get rid of that 6 right away so I don't have to deal with that fraction. Or I'm going to get rid of it now, I guess, not right away. But here's the deal. I have to acknowledge that I have an expression on the right-hand side. So if I multiply the left side by 6, I have to multiply the whole right side by 6. I show that by using parentheses. And now from here, I can go ahead and cancel out my 6's. I'm going to go ahead and distribute this 6, giving me 2x plus 4 equals 66 minus 6x. Now from here, I do not want to have a variable on both sides. I only want it on one of the two sides. So I'm going to go ahead and add 6x to both sides. I could also have subtracted the 2x if I wanted, giving me 8x plus 4 equals 66. I'm going to go ahead and subtract 4, giving me 8x equals 62, and divide by 8, giving me a final answer of x equals, since 62 and 8 are both even, I'm going to divide both of them by 2, and I get 31 over 4 as a final answer. Okay. So the big thing is that I can clear fractions by multiplying both sides by the denominator once I'm left with, one side containing only a fraction. So it doesn't have any extra, like for example, this had an extra minus 3 term that wasn't contained in the denominator. Notice I didn't try to get rid of a denominator up here in example 2 because I had an extra minus 6 term that didn't have a denominator, as well as a plus 3x term. Here, notice that everything was above the denominator. So up here, I did get rid of the denominator right away. So once you have only a denominator, or once you have one side completely all over the same denominator, you can go ahead and clear fractions.